Hello students, so today we are going to do exercise 1.3 from chapter 1 grade 10 maths, and here in this first question we have to prove that square root of 5 is an irrational number. And before doing this question, let's do a recap on what are rational numbers. So rational numbers are the numbers which we can write in the form of p by q, where p and q both belongs to integers. Both are integers, and where denominator is not equal to 0, it means q should not be equal to 0. And the third condition is HCF of p and q should be equal to 1, that is they both are co-prime numbers. These are the three conditions for rational numbers. Now we will be starting with the question number 1. We will be doing this question with the help of contradiction. Contradiction means we will assuming that square root of 5 is a rational number. So let's assume that square root of 5 is a rational number. So let's say this square root of 5 is equal to a by b, where a and b belongs to integers, b is not equal to 0, and HCF of these two numbers is 1. Now we will do cross multiplication and we will get a is equal to b times square root of 5. Now squaring both the sides, we will get a square is equal to 25. A square is equal to 5b square. Let's name this as equation 1. Now if you observe here that a square is divisible by 5, so this implies a is also divisible by 5. If the square of any number is divisible by any other number, then the number itself is divisible by it. Let's assume if we say that 25, that is square of 5, is divisible by 5. So 25 is square of 5. So it means 5 is also divisible by 5. So now using this we can say that a is equal to 5 times c, where c is any integer. So here c is any integer, and now again squaring both the sides we will get a square is equal to 25c square. Let's name this as equation 2. From 1 and 2 we can say that 5b square is also equal to 25c square. Here a square is equal to 5b square, a square is equal to 25c square, so we can say 5b square is equal to 25c square. Now we can say that b square is equal to 5c square, as we have cancelled these two. So now from here we can say that b square is divisible by 5. If b square is divisible by 5, this implies b is also divisible by 5. So let's say b is equal to 5d. Now we have just proved that a is divisible by 5 here, B is also divisible by 5. So this implies A and B both have common factor 5. So this implies A and B both are divisible by 5. Hence, HCF of A and B is 5, and we have assumed in the beginning that the HCF of these two numbers is 1. This is a contradiction. So its HCF is not equal to 1. So hence it is against our assumption. Therefore, square root of 5 is an irrational number. Therefore, square root of 5 is irrational number. Now we will do question number 2. In this question, we have to prove that 3 plus 2 square root of 5 is irrational. So again, we will be using the same contradiction method. We will be assuming, let's say 3 plus 2 square root of 5 is a rational number. So we can say that 3 plus 2 square root of 5 should be equal to A by B, where it is satisfying all the conditions that A and B belongs to integers. B is not equal to 0. HCF of these two numbers A and B is 1. That is, these two are co-prime numbers. So now we will transpose this 3 to other side. So it will be 2 times square root of 5 is equal to A by B minus 3. Simplifying this, 2 square root of 5 is equal to A minus 3B by B. So, and we can say that square root of 5 is equal to A minus 3B by B. Okay, now if we observe on the right hand side, A and B, these both are integers, and we know that if we subtract, add, multiply, divide, we do any operation on integers with the integers, we will getting the integers. So it means A minus 3B by B is a rational number. And what can we say about square root of 5? We have just proven in the previous question that it is irrational number. Square root of 5 is a irrational number. So it means they cannot be equal. We cannot say that these two are equal. So this is a contradiction here. So that is why our assumption is incorrect. So this implies that 3 plus 2 times square root of 5 is a irrational number. Okay, now we will do question number 3. In this question, we have to again prove that these given numbers are irrationals. Here also we will be using the contradiction method. We will take the first part. So we will assume that 1 by square root 2 is a rational number. Let's assume 1 by square root 2 is a rational number. So we can say 1 by square root 2 is in the form of A by B, where it is satisfying all the conditions of rational number, that is A and B belongs to integers, B is not equal to 0, and HCF of A and B is 1. So now by doing cross multiplication, we will get B is equal to a times square root of 2, and we can say square root of 2 is equal to b by a. And if we observe on the right side hand side here, b by a, this is a rational number, while square root of 2, it's a irrational number. So they cannot be equal. So this is the contradiction. So as our assumption is proved incorrect, so we can say that 1 by square root 2 is a irrational number. Now we will do second part of the third question. Here the given number is 7 square root of 5. So again, assuming that 7 square root of 5 is a rational number, so we can write this number in the form of a by b, where a and b belongs to integers, b is not equal to 0, and HCF of these two numbers, that is a and b, is equal to 1. So we can say that square root of 5 is equal to, now transposing 7 to the other side, a by 7 times b. Now what can we say about right hand side? Yes, so we can say that this is a rational number, and we already know that square root of 5 is a irrational number. And so these two cannot be equal, so our assumption is wrong. So we can say that 7 square root of 5 is a irrational number. Now we will continue with the third part, and the third number is given 6 plus square root of 2. Here also we will be using contradiction method. So let's assume 6 plus square root of 2 is a rational number. So we can say that 6 plus square root of 2 is in the form of a and b. Again, a and b belongs to integers, b is not equal to 0, and HCF of a and b is it's 1. So now we can say that square root of 2 is equal to a by b minus 6. So if we observe right hand side, we can say that a by b minus 6, it will be a rational number. Since a by b is a rational number, and if we subtract any rational number from it, we will get a rational number. It's a rational number, and we already know that square root of 2 is a irrational number. So we cannot say these two are equal. So it has proved our assumption is incorrect. So we can say that 6 plus square root of 2, hence our assumption is incorrect. So we can say that 6 plus square root of 2 is a irrational number. Hope this video was helpful to you. Don't forget to like and share. Thank you.